Hi Eric.
Hi.
We are to the PDC today. We are very pleased to make the interview with you. The first question is about your job. Can you describe your job at Microsoft?
Sure. So I work on the parallel computing platform. Particularly, I spend most of my time focusing on native programming models for concurrency. So I'm focusing on the parallel pattern library, the asynchronous agents library, and how to actually use them and integrate them into products, and hopefully provide some utility so that you can actually speed up your applications using these versions.
We noticed the Microsoft Parallel Computing Initiative was defined a few years ago.
Mm-hmm.
Today we are very close to the release.
Yeah, it's incredibly exciting.
For your opinion, have you achieved your goals? From the beginning,
yes,
and now
we have a lot, I think we have a lot further that we can get to, right? And so if you can say, our goal is to enable you to express the concurrency in your application. Whether I'm talking about managed or native, so you can say, here's some tasks, here's some loops, here's some dependencies. To that extent, I think we've done a really good job, both in the parallel pattern library, the agents library, in the task parallel library. We've done a wonderful job, and it's a lot easier than it used to be. You don't have to spend your time focused on building the infrastructure, designing the infrastructure, making sure the infrastructure is right. Oh yeah, and then at some point you get around to actually doing the work that we're all supposed to love doing or get paid to do, which is the particular domain, which is not writing threading models. So to that extent, we've succeeded. I think we've also made a lot of forward progress in the tooling and sort of visualizing threads, visualizing tasks. There's a significant breakthrough from a list box with a bunch of threads in it. You click on each one of them and you see a bunch of call stacks. Rather you can say here's my tasks, here's my threads, here's how they're related to each other. I can actually navigate by looking at them and actually get to the code. You can sort of see the tasks and see if they're blocked, see if they're not blocked, see if they're dependent on each other. Yeah. That's really wonderful too. It really makes it a little easier for you to actually figure out what's going on with your code. To the extent that we made your code more thread safe or more correct, we have a lot of areas to work with, right? We did add some containers, but we've really just scratched the surface.
I see you provide some extra code sample to implementing some other patterns, so not included in the official distribution.
That's right.
Do you plan to integrate it by default in VS?
Do we plan to integrate it by default?
Yeah.
Someone asked us on the blog, I think a couple days ago. It might have been you. So we don't, of course, have official plans to integrate things in future products, but they are there. They were built by the team. They're things that we think are useful.
Yeah, very useful.
Yeah, incredibly useful in some cases.
Yeah.
Some of them are things that perhaps, if we had more time, we might have been able to get them in or not. But as always, if you give us feedback about things, if you say, well, you provided this, but what I believe is this, give us the feedback, tell us you're using it so we can actually use that to deliver the next wave of product. You can also use these, and the other big motivation forces, you can use these as examples, right? Because we know we have a set of things that are in the box, but we only provide so much. Right, and one way of thinking about the parallel pattern library, it's a library that you can use to build your own parallel patterns. Right? This is a way, so here's some common primitives, here's some common loops. You can actually take these loops, compose them together, and build additional loops, build additional objects, build additional structures that are related to what you're doing. Right? Because if you read any of the patterns books, it's talking about a pattern. And what you do with patterns, you produce an implementation of a pattern.
Exactly.
And that's what we want to make it easier for you to do, is actually build those patterns.
For C++ developer, have you any advice on when we should use OpenMP or PTR?
When you should use OpenMP or PTR? Yeah, I get this question a lot, actually. It's a really good question. So if you're already using OpenMP and it's working well for you on all the platforms you support, you're using it, it's working well for you. There it is. Now, if it's not working well for you, or you're looking, to doing something additional, right, or to compose things, because one of the big things we looked at to change, why did Microsoft do PPL when we had OpenMP?
Yeah.
PPL is more than loops, right? OpenMP, at least OpenMP 2.5, which is what we provide.
You have a green badge. You need to vacate, please. We're closed.
Anyway, it's okay.
Just for the green badge. Sorry.
But the thing that's incredibly important is composability, right? So I'm building a library. That library has some concurrency in it, has some parallel loops in it. I'm going to call that library with the data that I build up, that I call. And the piece that's harder with OpenMP is to say, this is the kind of concurrency I want based on this composed library. If it's a series of loops looped together, like I showed at the top, where I think I had a parallel transform with a parallel countif inside of it, followed by a parallel accumulate. All of every one of those were things that were in the extras pack, and actually chaining those together and nesting those, and being able to say, here's my library that does this. Here's the data to do this. Oh, now I'm running in a service. So in that service, I want to run on 2 threads because it's a background service and I don't want to be sure. Now actually it's right behind a button in a GUI and I own the machine with some productivity app or entertainment app, and it's totally fine. And that was one of the key things. The other piece about composability is to say, if I have 5 loops nested together running in a task, and the system is busy running a bunch of other tasks, there's no reason to spin up a bunch of other threads to do that. That's just going to add overhead. Let's add overhead in the concurrency runtime itself as we need it, and let you focus on describing the concurrency, and let the runtime focus on figuring out how to run it, and figuring out how to give you scale video, whatever is on your platform, so that you write something once, and it runs well on your dual core, it runs well on your quad core, it runs well on your hyper-threaded media processor, it runs well on a NUMA box. That's the key thing that's different.
Okay.